class. Last time we were able to start on rectilinear propagation of light. We were able to mention around 6 concepts. Those concepts were to do with some properties related to light. We talked about luminous objects, non-luminous objects. We talked about opaque objects, translucent objects, and transparent objects. So we talked about 6 objects: luminous, non-luminous, transparent, translucent, and opaque. You have to remember that. So we talked about array of light. When you talk about array of light, we mentioned that that is the path that light follows. If we have many rays, we refer to that as a beam of light. Then we mentioned 3 types of beams of light. Hassan Ahmed, can you remind us of the 3 types of beams of light? Yes, Hassan Ahmed. 3 types of beams of light. The first one. Hassan Ahmed seems not to remember. Okay. Who is ready to give us the 3? Abdul Basit, name for us the 3 types of beams of light that we learned.
Convergent.
Good.
Divergent. And parallel.
And parallel. That's very good. That's okay. Now, Mohammed Abdallah, can you give us the difference between translucent objects and transparent objects? Mohammed Abdallah, the difference between translucent and transparent.
Translucent, light can pass through, but you can't see.
But you can't see through them. Good. Transparent?
Transparent it is. Light passes through and you can see through.
Very good. So that's Abdallah Mohammed has given us that. Now, Hassan Ahmed, name 2 types of shadows. Okay, Hassan Ahmed, 2 types of shadows. The first one.
Umbra.
And then?
Penumbra.
What is the difference between them? That's very good. The difference between them?
The difference between umbra and penumbra?
Yes.
Umbra is when the source of light is near to the where the source of light comes from.
So the source of light is near the object.
Yeah.
The other one?
And penumbra is when the source of light, the object is far away from the source of light.
That's a good try, Hassan Ahmed. Anyone else with a different opinion? The difference between umbra and penumbra. Zamzam, can you try to support what Hassan has given us? The difference between umbra and penumbra. Try. Yes.
Umbra is the most dark place and the penumbra is slightly dark.
So she's telling us that umbra, there is one which is slightly dark and another one is very dark. That's true. So let's remember that umbra is a shadow of total darkness. Yeah, that is umbra. That's a shadow of total darkness. Penumbra is see P for partial. So penumbra is a shadow of partial darkness. Now, I want somebody to remind us, what is it that will lead to a shadow of partial darkness, and what will lead to a shadow of total darkness? When do we have a shadow of total darkness? I hope we all know how to raise up the hand. Mohsin Shafi. Let me unmute you.
A small or a point source of light leads to umbra.
Very good.
A small or a point source of light leads to umbra, and a
Yes.
bigger source of light leads to formation of penumbra.
Very good. That's good, Hussein. So, a large source of light will lead to penumbra. Of course, umbra will also be there. A small source of light will only give us umbra, the shadow of total darkness. Now, as we went on, we started talking about evidence to show that light travels in a straight line. You can remember the three evidences. Three evidences to show that light travels in a straight line. Abdi Adud. Any evidence that you know in everyday life that this shows that light travels in a straight line?
Formation of shadows.
Formation of shadows, very good. Any other? Weather. Any other evidence to show that light travels in a straight line?
Occurrence of eclipse.
Occurrence of eclipses. That's correct.
Image formed in a pinhole camera.
An image formed in a pinhole camera. So please remember the three evidences. You see, as we are reviewing this, try to remember evidences to show that light travels in a straight line. Now, when we are talking about light traveling in a straight line, what do we mean by that? What do we mean by saying that light travels in a straight line? Hassan Ahmed. What other terminology can we use to show that, or to mean light traveling in a straight line?
Linear propagation.
Yes, repeat.
It's linear propagation.
So, rectilinear propagation of light. That's very good. So, we had we've done the shadows. So, the size of the shadow will depend on the source of light, the size of the opaque object, and the distance between the object and the source of light. That's how shadows are formed. But we had gone to the formation of shadows. We had looked at the umbra, penumbra, all that. So we wanted to look at the eclipses. So for shadows, I want you to remember these 3 points, that the type of shadow formed will depend on the size of the source of light. If it's a point source of light, then it will be a shadow of total darkness. Only the umbra shall be formed. Then also the size of the opaque object. If the object is bigger, then the shadow will be of total darkness. If the size of the object is smaller, then we shall have both umbra and penumbra. Then of course, somebody was mentioning the distance between the object and the source of light. So these are the 3 factors that will determine the type of shadow that is formed. So when you look at the first one, if it's a point source of light, so this is a small source of light, this is the opaque object, we only have the umbra. That's total darkness. If we have an extended source of light, that's a large source of light. You can see the rays of light as they go. So if it's a large source of light, we shall have both umbra and penumbra. Now, when you look at extended source of light is the same as a large source of light. So you see, if the source of light is too large, then umbra is too small, but the penumbra is going to be too large, as we can observe on the screen. This is an extended source of light is the same as a large source of light. And you can see, if the object moves away, when the object moves away from the object, you can see this is total darkness, then partial darkness. But if the object is closer, as it is in the previous, you see it's closer. You see the umbra is too small. When the object is closer to the source, the penumbra is larger than the umbra. But as the object starts moving away from the source, you see the umbra starts growing bigger. Salma Ali is going out, on, and off. Okay. When the ball is far away, there is umbra surrounded by penumbra. But if it's near, we have total darkness only. Now, the other evidence to show that light travels in a straight line is formation or occurrence of the eclipses. So eclipse can only occur if we have the sun, the moon, and the earth on a straight line. When the three are on a straight line, then it's possible that we can have what we call eclipse. So the meaning of the word eclipse, to eclipse is to block light. So like in this case, when we talk of eclipse of the sun, also known as solar eclipse. So the moon will eclipse light from reaching the earth. That's solar eclipse or eclipse of the sun. So the moon prevents light coming from the sun from reaching the earth. So the moon will be between the sun and the earth. So when you look at these diagrams here, okay, we should use this torch to show you. We can look at these two diagrams. We have the sun, we have the moon, and let's take that this is the earth. So when the solar eclipse takes place, it can happen that the moon is closer to the earth or it's away from the earth. So if the moon is closer to the earth, then we shall observe, you can see this, we have the umbra and we have the penumbra. So at point A, this center we have total darkness, but at point C, you can see we can have partial. But at B, if the moon is closer to the sun than the earth, then we have what we call an annular ring or a ring eclipse. So at point A, total eclipse in the umbra. So at this point, the moon is closer to the earth. That's what's happening. Then at point B, this is where we are seeing the moon is away from the earth. So while we are on the earth, we shall see a ring around the moon. There will be a ring around the moon. On occasion, when we have the moon being closer to the earth, the night becomes totally dark. Totally dark. Here we see the ring. This happens mostly during daytime. We're able to see this annular eclipse where you can see the moon in the sky, but it has a ring around it. Then of course here, part C, this is partial eclipse. So what is it that they'll ask you about the eclipse of the sun? You have to remember the shadows. When an opaque object is closer to the source of light, then we have umbra and penumbra. When the opaque object, in this case is the moon is just an opaque object. It only reflects light from the sun. If it's far away from the source of light, then you can see what's happening. We shall have the umbra and penumbra. But now the umbra is bigger here. But here the umbra is too small. So that means when the moon is closer to the sun, the shadow of the moon does not reach the earth clearly. You see here the shadow of the moon, the total eclipse here, this part of the umbra, is not able to reach the earth. So we shall just see a small point, and of course we see partial darkness around the moon. So an eclipse can only occur when we have the sun, the moon, and the earth on a straight line. Remember this. The moon and the earth. There is one which rotates around the sun, and that is the earth. So the earth keeps rotating around the sun, for those of you who might confuse. And the moon rotates around the earth. Very important. So if the earth is rotating around the sun and the moon is rotating around the earth, it happens that at one point, the sun, the moon, and the earth are on a straight line, and therefore there an eclipse will take place. So what you have to remember, what happens when the moon is far away from the sun and closer to the earth, and if the moon is far away from the earth. So these are the happenings that you have to remember. Anyone with a question there? I want to observe this. So that was the eclipse of the sun. The moon is in between the sun and the earth. And remember, the earth revolves around the sun and the moon revolves around the earth. So don't confuse and say the moon rotates around the sun. No, the moon rotates around the earth and the earth rotates or revolves around the sun. So eclipse of the moon, that means the moon does not receive light. So if for the moon not to receive light, it means the earth has passed between the sun and the moon. So another thing which I want to clarify, just to remove the confusion, eclipse of the sun mostly occurs during daytime, but eclipse of the moon occurs at night, mostly at night. That's when we observe eclipse of the moon. So when you say the moon has been eclipsed, what eclipses the moon is the earth. The earth always will cast a shadow on the moon. So also it will depend on whether the earth is closer to the sun or closer to the moon. So in this case here, the shadow of the earth prevents light from the sun from reaching the moon. This makes the moon unable to reflect any light to the earth. This eclipse only occurs at night. So there is a shadow, evidence that light travels in a straight line. So remember those two types of eclipses, the solar eclipse and the lunar or the eclipse of the moon. Now here the pinhole camera, let's try to supposing we have a box with us. I have this. And I have something like the screen. I have a screen behind here. And I have a small pin I'm going to leave somewhere. And I have an object. So I'm putting the object to be here. This is the object. So this top end is the head, and this is the bottom. And now a ray comes from the top through the pinhole it goes there. Then another ray comes from here to the pinhole, it goes to that end. Then I can put an arrow to show that this ray was coming, then it went straight. Then this ray was also coming from here, then it went straight. So the rays which are coming from the top, the ray from the top, you see, it goes directly to the bottom, and the ray from the bottom goes directly to the top. So in that case, our image now, when we draw our image, this is how our image will look like. That's our image. So when you see this image, you can give the characteristics. What I've drawn in blue here is the screen. So this image is being formed on a screen. The image is also inverted. So when we are giving the characteristics of this image formed in a pinhole camera, the first point we have to remember is that it is inverted. And it is also real. Why are we saying real? These are actual rays. These rays are real rays, so they meet on the surface of the screen at that particular point. So because the image is being formed from actual or real rays, so we call it a real image. And also, it is being formed on a screen. So in the exam, you can be asked to use a diagram to show how a pinhole camera forms an image. So this is what you show. Just draw that box, show the screen, draw a line object with an arrow at the top, then you draw the rays. Can I allow you to sketch that? 2 minutes. Draw a ray diagram to show how a pinhole forms an image. Make sure that the rays intersect exactly at the pinhole, a small hole there. Then put an arrow at the top of the object. Then on every ray, you show an arrow outside and an arrow inside. Hussein, are you through? Hussein Shafi, are you finished?
Yes, Mualim, I'm through.
Whether have you finished drawing?
Yes.
Just show you a diagram on the screen. Whether show you a diagram on the screen, let me see it. Just put it on the screen, I'll be able to see it. Oh, put the diagram close, I'm not seeing. Just place it on the screen directly, I'll see it. On your screen directly. Push it up, 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 up. Okay, try to use a ruler, please. Use a ruler. Okay. Now, so the pinhole camera, the image, the way it has been formed, shows that light travels in a straight line. We can see in the first place, images in a pinhole camera. That's, you can see the rays. This is where the eye is, so the image is inverted, and it is real. Compared to the object, you can see this image is smaller. We want to look at other characteristics. Now, when we see the object near the pinhole, so this object is near the pinhole, and here the object is away from the pinhole. So the object distance. Now, I want you to use your eye to give the characteristics of the image formed when the object is near the pinhole and when the object is far from the pinhole camera. So it's just like you, when an object you are seeing, like an animal or human being, is very far from you, the image you will see is too small. But if you are closer to an object, assuming that your eye is the pinhole, if your eye is the pinhole, yeah. So here we see the object is closer, so the image is bigger. The image is larger now. But if the object distance is bigger or greater, you can see the object is too small. But for you to remember this question, if they asked you to describe the image formed by a pinhole camera when the object is near or far, just imagine using your human eye. When you are closer to an object, you will see the image in your eye to be bigger. But if it is very far, you will see it to be very small. Say, for example, you are in a car on a road which is very straight and very long. You will see some animals, some objects to be too small, but as you move closer, they become bigger. So that's how you answer the question to do with object distance. Now, apart from object distance, it's also possible that we can vary the image distance. And I want to demonstrate, assuming the object distance remains constant. So I'm taking that this distance does not change. So that distance just remains. Let's give it a name D. It just remains there. And then we are now going to vary this other distance. So we make this distance to be longer. So the distance in front here, D, we call it the object distance. That's the distance from the object to the pinhole. So that's the object distance. Then the distance behind here, the one I've drawn, we are calling it the image distance, the distance from the pinhole to the screen. So extending my screen, let me extend the screen. I've extended the screen to be behind here. So that's where the screen is. Now let's look at what's going to happen to that. And then after extending that, now let's look at what's going to happen to this ray. Supposing this ray now extends further. Then I also extend this ray. So I've extended those rays to show that that's how the image, that's where the image is going to be formed. I've also extended this one. Now we want to see that now our image is going to be on this screen because we moved the screen behind. So this is going to be the image. Now look at that other characteristic. The first part we were varying the object distance, but now we have varied the image distance. You are holding the pinhole camera, but you are now pulling this screen. The length of the camera has been increased. So you can see the characteristic of the image. The image becomes larger. So when the object distance is smaller, the image formed will be larger. But if the object distance is larger, the image formed will be smaller. When we come to the screen here, when the image distance, this distance is smaller, so if it is this first one here, if the image distance is smaller, the image formed will be smaller. But when you increase the image distance by pulling the pinhole camera, increasing the length of the pinhole camera, you can see the image is larger in size. I allow you to write something on your own concerning the object distance and the image distance. Write something concerning the object distance and the image distance. So object for you is object distance. And this one behind we are calling it the vimage distance. Write down something short on what you have understood. You know, when you make your hand to be active, you will remember. But if you just wait to read the notes that you will print, you might not remember. So you are talking about object distance. So what are you saying about object distance in your short notes? When the object distance is bigger, the image is smaller. When the object distance is smaller, the image formed is bigger. Then talk about the image distance, the one I've just illustrated. When the length, now image distance is the same as the length of the pinhole camera. When the length of the pinhole camera is smaller, the image is also smaller. When the length of the pinhole camera is bigger, the image is also bigger. In other words, smaller image distance, smaller image. Larger image distance, larger image. So it is directly proportional. Image size of the image is proportional to the size of the image distance. But for the object is the one which is inversely proportional. Okay. So allow me to. Now, apart from the effects of image distance and object distance, we can also have an effect whereby the pinhole, instead of just having one small pinhole, they put many small pinholes. Okay, I'm just going back slightly. Somebody's asking a question here. I've gone back slightly. So remember last time we watched a video which was showing how a pinhole camera can be formed. My sound system has failed today, so next time we will be able to show you that video once again. So the pinhole is just a box. Then there is a hole in front. Then you can see there is translucent paper behind here. So this will act as the screen. And then in the front, this hole, you just use a pin to make the hole. Now, the object can be placed in the front there. Then you view from behind the box. That's somebody has asked that question. The teacher, go back and just explain how that box works. How does it work? So I've just gone back. I'm answering your question, please. So you are viewing from this end. You have just used translucent paper to act as a screen. And then that box, of course, inside you have painted it black. Inside is painted black to absorb any stray lights. So the light will enter through this hole and the image is going to be formed on this translucent paper. So your eye is on this side. You are viewing from behind here. So when you view from behind there, the object is placed in front. This is how the rays come and form the image. So the top part of the image becomes at the bottom, and the bottom part goes to the top. So when this image, when you look at this image and relate to the object, the image is inverted, or it is upside down. That's very important for whoever has asked that question. So that's how the rays formed. Now, in the first case, we have now looked at the characteristics of the image formed by a pinhole camera when you vary the object distance. This one here, you are varying the object distance. This one is the object distance. When we vary the object distance, it is inverse. The image formed, the size will be inversely proportional. In other words, we look at the next diagram. In other words, when the object distance is as it is here, you can see this object distance, then compare this object distance. Please, I'm answering the question for one of you. So this object distance is small. Then look at the size of the image. It's bigger. And then this object distance is too big. The image is too small. So here, that's where I was telling you, in this case, when they are talking about the size of the image in relation to the object distance, use your eye. How do you view the size of the image when the object is very far? Some of you have used aeroplanes. When you are very high up in the sky, you see a human being appears like a dot. But as you start coming closer to the ground, you can be able to see now clearly the human being or the objects, they become more clear. So when the object distance is too big, the image is too small. But if the object distance is too small, then the image is bigger. That's the first clarification for the question I've been asked. I go to the second clarification, which was to do with the image distance. So if you use a pinhole camera which is longer, is just the same as extending these rays. You just extend these rays, you extend that ray to go, and also extend this ray to go. So you see, as you extend those rays, you can see clearly that you can see what's happening to the image. This is the image. As the rays move away, you can see this is the image. So as the length of the pinhole camera increases in size, the size of the image also increases. But as the length of the pinhole camera decreases, the size of the image also decreases. So that's why I was concluding that when you're talking about the image distance, it is directly proportional to the size of the image formed. So the larger the image distance, the larger the image formed. The smaller the image distance, the smaller the image formed. So that's how you do when you are asked that question. Now I was moving on to when we have so many pinholes. So this is the first pinhole, then you make another pinhole there, another one here, another one here. So what happens in that case? So this is what happens. If we have so many pinholes, each pinhole is going to make an image. So for instance here, you can see there is this image here. There is another image here. You can see each pinhole, this first hole, it forms that image. Then this second hole forms another image. You can see the images overlap. This image has gone up to here and the other one starts exactly from there. So they are overlapping. So many pinholes will allow in light. So each pinhole will form its own image. And because there are so many pinholes, they will form overlapping images. And those overlapping images, they will form one image which will be enlarged and it will be blurred. I want you to see this terminology here, blurry. To be blurred, it means the image is not clear. So many pinholes will produce overlapping images on the screen. This one here, overlapping images on the screen. I've shown you how the images will overlap. So each pinhole is forming an image. So the image will lie on each other. That means overlapping. And therefore, they form one image which will be very large, and that image will appear to be blurred. So you can see the image could be large but blurred. It will not be very clear, as you can see in the diagram. So those very many overlapping images will add up together to form a very large image, but it will be blurred. It will not be clear. So that's a point for you to note, that a brighter but very blurred image is seen on the screen. So having many pinholes is like having one hole which is very large. A large pinhole is the same as many pinholes. So what will you observe on the screen? You will see a brighter but very blurred image on the screen. 1 minute for you to put down what you can summarize from that. The effect of many pinholes. Effect of many pinholes. Effect of many pinholes. What's the effect of many pinholes? So you're just making a summary. So we have said overlapping images. These overlapping images are equivalent to a brighter So the many overlapping images are just the same as a brighter but blurred image. Then, effect of a larger pinhole. That's the summary we put, effect of enlarged pinhole. Then we put a dash, effect of an enlarged pinhole. The same thing, you quote this, a brighter but blurred image is seen on the screen. Okay. All of us have put that short summary. We move on to the other characteristic. This is what I've already shown you. Length of the camera reduced. This is the object distance remaining fixed. Then you keep on varying the length of the image. Effect of changing the length of the camera. So when the camera is longer, the image is larger. That we have already discussed. Now, as we finish the pinhole camera, we need to talk about the advantages and disadvantages of a pinhole camera. That's a common question in exams. Advantages and disadvantages of a pinhole camera. So a pinhole camera does not require any focusing. That's one of the advantages. The main advantage, A pinhole camera does not require any focusing. There is no knob. There is nowhere where you try to adjust so as to focus. But the other cameras that we use, we must be able to focus. But the disadvantage of the pinhole camera, the exposure time is too long. You must stay there for a longer time. And then again, you cannot take pictures of moving objects. The other cameras, the object is moving, then you just take the photograph. But a pinhole camera, disadvantages are two. One, the exposure time is too long. And the second disadvantage, you cannot take photographs of moving objects. You can quote that summary, advantage and disadvantage of a pinhole camera. The advantage, we have put it there. Does not require any focusing. That's the advantage of a pinhole camera. I don't need to focus. But the disadvantages are two. One, exposure time. You will put the camera there and wait for a longer time for the image to be formed. So the exposure time is too long. But the other cameras, you simply press the button and the photograph is taken. And then moving objects, you cannot take photographs of moving objects. Something related to the pinhole camera that we call magnification as we come to the end of the lesson. I want us to pay attention on how to calculate what we call magnification. So magnification, like those of you who are doing biology, when you talk of magnification, is comparison between the size of the object and the size of the image. How do you compare them? In physics, whether the image will be smaller or bigger, we still talk about magnification. So we can have positive magnification, negative magnification. So if we take the size of the image and compare to the size of the object, we call it magnification. The ratio of the size of the image to the size of the object. So size talks about the height h. So HO, height of object. HI, height of the image. So if we take the height of the image, divide by the height of the object, that is magnification. Then we have the image distance. So I tell students to pronounce it as vimage. When you say vimage, you will remember that V stands for the image. Then object, object. U, that's the U to stand for object distance. So when you take the vimage distance, then you divide by the object distance, it also gives you magnification, as you can see from this formula here. So that's why when you're asked to define magnification, it is a ratio of the size of the image to the size of the object. So when relating the two formula, we say he/ho is equal to VU. He/ho, that's height of the image. In fact, just remember magnification is he/ho, where he for height of the image, ho height of object. So magnification is the same as he/ho. And then where HI stands for the image, then when you come to the distances, you'll also say VU. So he/ho is equal to VU. So look at the two formula. Then we do some one or two worked examples. We are just relating the size of the image to the size of the object. So image over object. Don't confuse and take object over image. It's image over object, image over object. But above all, just remember he/ho. If you can't remember hee-haw, just remember the sound produced by a donkey. When a donkey is very angry, you'll find it producing that sound, hee-haw, hee-haw, hee-haw. Just that alone will help you remember magnification, hee-haw. Now, one example. It's given here. The distance between the pinhole and the screen of the pinhole camera is given to be 10 centimeters. Of course, this diagram is now a solution. So you always sketch, then you insert in the values. The height of the screen. When they talk of the height of the screen, take it to be the height of the image. So whenever you see the height of the screen, that is the height of the image, the Hi. Then at what minimum distance from the pinhole must a man 1.6 meters tall? At what distance from the pinhole must a man? A man is an object. So that's the asking for the object distance. And the height of the man has been given. So you can see these measurements. Some are in centimeters, others are in meters. So it's good for you to convert all of them to be in 1 unit. You either convert all of them to be in meters or convert all of them to be in centimeters. Let me go back to hee-haw slightly. This height of the image is in centimeters. The height of the object is also in centimeters. So if up here I have centimeter, and down here I also have centimeter, this is clear that the centimeter and centimeter will cancel out. So this centimeter cancels out and this centimeter will cancel out. So magnification has no units. So M has no units. That's what I want you to remember. Magnification has no units because it is a ratio. That's a point I was forgetting. It's very important to know that magnification has no units because it's a ratio. So from this example, once you write hee-haw is equals to VU, you'll be able to work out and get the answer. Now example 2. So let this be our last example, but everybody is now doing it. You don't copy the question because you already have the notes. I want you to show the working. Then you send a message on the screen, send a text message of your answer. Okay, start doing it. As you finish, you send your message and be able to see your answer. So I have not received any message. There's a place on your computer, you just text. Just text a message, and then I'll be able to see the answer. Anyone who has done? Okay, 3 people. So Mohammed Abdallah. Abdul Basir. All right, 500 meters, 0.05 meters. Others, Zamzam, Hussein Shafi, I'm waiting. Mohammed Abdallah, Waida, Hassan. So object of height. So you always start by just write object of height. So you write hi, give the value, then ho, give the value, very important. You identify all that. He, ho, then we have the v, give the answer, then you give record. So hi, an object of height. So object 5 meters. So this 5m, I'm showing this, then we find out who is right. Height of the image. So then answers coming in. So the size of the image, so they're asking for the size of the image in the first place. So I put a question mark. They're asking for the size of the image. Size is the same as height of the image. So an object of height that is placed 10 meters away. So object distance, it is 10 meters. So we are being asked for the length of the pinhole camera. So the second part. So that means we are doing part A. We are doing part A. So we are doing part A. So when you are doing part A, magnification is given. So magnification, it is given by he, ho, or vu. But because they're asking for the size of the image, which is the height, so in this case, our magnification, which is 0.01, 0.01 will be equal to he, ho, which is hi, then divide by ho. Ho is the 5 meters. So 5 meters. So in this case, who is right? So our he will be equal to 5 multiplied by 0.01. So it will be 0.05 meters. So if I check the messages, you will find there are those who got 0.05. Whoever got 500, I think you converted to centimeters. So part A, the size of the image. Please remember when you talk about size of the image, so many messages coming in. Let me see who has got it right. Okay. So 0. Abdul Basit got it right. Mohsin got it right. Abdul Basit, you got 0. Oh, that's Roman 2. Roman 2. Roman 2, all of you got it right. So whether this 0.5 your multiplication, just the multiplication part, and Mohammed Abdallah, you got 500 meters. So just look at the multiplication. So most of you got 0.5, that's correct. And then when we go to part B, who is right? So the length of the pinhole camera is the same as asking for V. So magnification in that case is going to be equal to VU. VU, we are just about to end. VU. So this implies that our magnification, which is 0.01, will be equal to, when you look at the information given there, we don't have V. We don't have the V. So in our substitution, we have V over U. U is the 10, which is in meters. So that means our vimage distance, is going to be 10 multiplied by that. And I'd seen most of you had got 0.1. Yeah, that's very good. Okay, that's very right. That's very right. So most of you got it right. That's very good. Let me see. Okay, that's nice. Our time is up. Let's just take some 5 minutes, please. Because I've seen most of you have got the other question very well. I can just maybe let's just take some 5 minutes to do this example 3. Then after you finish the answer, just send the message. The first one to send the message, I'll just announce your answer, or I'll hold until everybody finishes. I'm liking the way you are responding to the questions. That's very good. Keep it up. Remember to identify the he, the ho, the v, the u. And then apply the formula he, ho is equals to vu. Somebody has already done. Good. Let's see the first person. Abdul Basid. Already finished. So I can see Rueda, Abdallah. Good. That's Mohammed Abdallah. Muslim Shafi. Okay. Good. Abdul Basit has come in. Hassan Ahmed has come in. Abdul Basit Abdullahi. Good. Yeah, others are getting 20 centimeters, others 0.4 without units, others 4 centimeters, 0.64 without a unit, 0.04, without a unit. Zamzam has done 0.4 meters for Zamzam. Let's see who will be right. Okay. So who is right? So we start with our HI. Is it given? A photographic film of pinhole camera is 20 centimeters away. So we write pinhole, like put equal sign, we write our V, put equal sign, write our O, then we put equal sign. So each one of them. So a photographic film of pinhole camera is 20 centimeters away. A photographic film. So the film is 20 centimeters away from the pinhole. So that is the image distance. For those of you who might have confused, so we are being given to be 20 centimeters. A photographic film of pinhole camera is 20 centimeters away from the pinhole. So that's the image distance. A student of height, so height of the object, 1.6 meters, 1.6, you remember it's in meters, stands 8 meters from the pinhole, so 8 meters from, so this is the object distance is 8 meters. Find the height of the students, so height. So in this case, we use our he-ho to be equal to our VU. Then we substitute our he-ho, we don't know our HI, that's the one we are looking for, should be equal to, so this is our ho is 1.6. Because we have centimeter mixed, we convert everything to be centimeters. 1.6 meters will be 160 over 160. So this will be all over 160 centimeters. It's good to quote this unit so that you don't confuse. Then should be equal to our V. Our V is 20 centimeters. And then it's over our VU. Our U is 8 meters, which is 800 centimeters. So you can see we are going to have 20 over 800, then we multiply by 160. So 20, then it's divided by 800. I get the answer to be 0.025. Then I multiply by 160. I'm getting the answer to be 4 centimeters. So our HI is equals to 4 centimeters. So if it is the case, let's see the last ones to bring. Mohammed Abdallah, you said your answer should be in meters. If it's 4 or 0.4 meters, correct. Zamzam, yeah, conversion to meters. So that's correct. Hassan Ahmed, you got 0.64. Let me check. Mohsin Shafi, correct. Mohammed Abdallah, you didn't put the units, correct. Raida, 20 centimeters. Yeah, that's it. So that's very good. So that's how we go about these questions for that. So in our next lesson, we shall be able now to move on to something slightly different from the pinhole camera, and that's looking at the laws of reflection. So class, what did we learn today? Today, our emphasis has been on the pinhole camera. The characteristics of the image formed in a pinhole camera, which the first one we said, the image is upside down or inverted. That's the first characteristic. The second characteristic, the image is real. So inverted and real. Then we have looked at the various effects. Effect of object distance, effect of the length of the pinhole camera or the image distance. Then we have looked at the size of the pinhole and if we have many pinholes. And we have gone further to look at how to find magnification. We have looked at magnification as a ratio and it has no units. A ratio of the size of the image to the size of the object. So please remember, when you talk about size of the image, is the same as the height, and the size of the object is the same as height of the object. And I'm reminding you to use the formula he/ho is equals to VU. If you find yourself forgetting to calculate magnification, remember the sound of a donkey. He-ho, he-ho, he-ho. When the donkey is hungry, that's the sound it produces. So if you remember he-ho, that will be the way to calculate magnification as related to the pinhole camera. So that's up to that. I want to appreciate your activeness in doing the calculations and sending your answers. Let's keep it up. I want to end there.